This presentation will briefly look at snow loads on roof structures. We will look at a snow load map for the upper Midwest, review the snow calculations in building codes and the difference between Category 1 and Category 2 buildings, along with the weights and heights of snow on roofs. The map shown here is the ground snow load map from the building codes. The numbers shown are in pounds per square foot, or PSF. This would be the base number used in order to calculate the design roof snow load per code for any structure. You can see the map outlines of Iowa. The ground snow load goes from 40 pounds per square foot at the Minnesota border down to 20 pounds per square foot at the Missouri border. One of the first steps in calculating out the snow load required on roofs is to convert the ground snow load from the map to a flat roof snow load as shown in this equation. P sub F, flat roof snow load, equals P sub G, the ground snow load from the map, times 0.7, a factor built into the equation, times C sub E, exposure factor, typically 0.9 or 1, times C sub T, the thermal factor, typically 1 or 1.1, times I, the importance factor, typically 0.8 or 1. So if we look at taking a building located in Missouri, a piece of F, the flat roof snow load, would equal 20 times 0.7 times 1 times 1.1 times 1, which would equal 15.4 pounds per square foot. The next step would be to convert the flat roof snow load to a sloped roof snow load, assuming the roof has a slope. The C sub S factor is based on roof type, slope, and the thermal factor. In this example, the sloped roof snow load would calculate to 13.86 pounds per square foot. The building category determines the importance factor used in the snow load calculations. A Category 1 is a low-risk structure which typically includes most ag buildings. A snow load importance factor would be 0.80. Category 2 is a modest risk structure which includes residential and most light-framed commercial buildings. This importance factor would be 1.0 for the snow load equations. The equations above show the difference between the base flat roof snow load for a Category 1 versus a Category 2 building. Please note that these are just base snow load calculations and other factors can affect the snow loads on the structure. Minimum snow load requirements and rain on snow can affect these numbers. The table shown here shows that a light, dry snow can weigh 3.12 pounds per cubic foot, and a heavy, wet snow can weigh as much as 20.81 pounds per cubic foot, and a layer of ice 57.25 pounds per cubic foot. It all depends on how much water is in the snow. If we assume a design load of 30 pounds per square foot was used, a light and fluffy snow could be as high as 9 feet before exceeding the design load. A heavy wet snow would only be 1.4 feet tall before hitting the design load. Keep in mind, if it's all ice, the height would be around 6 inches. Note, you will not know how heavy the snow is on your particular roof or how much ice is included. Also, you may not know of any possible construction defects that could affect the capacity of the structure. This photo shows a partially collapsed structure. The snow load was made up of several layers of ice and heavy snow. Keep in mind that this structure also had some truss bracing issues, which made it weaker than designed. This photo shows a partially collapsed structure. This snow load was made up of several layers of heavy packed snow that was on the roof structure for a long period of time. In summary, the weight of snow can vary greatly. If installed and braced properly, trusses should be able to support 1.4 feet of heavy snow when designed with 30 pounds per square foot. Inspecting the roof structure and snow depth might be advised, and removal of snow and ice if needed. Any questions or concerns, you can contact SBCA at www.sbcindustry.com, consult a local professional engineer, or consult with your truss manufacturing company. Thank you.